So I can start now. Hey everyone, I'm Nikhita, and I'm here to give an introduction about what it means to be cloud native, how you can move from cloud to cloud native, and how you can also get involved in these technologies and contribute back from an Indian perspective. Um, so, a little bit about me. I live in Mumbai and I lead the upstream Kubernetes team at VMware, and I'm also on the Kubernetes steering committee, which is the main committee or the main body which governs the whole Kubernetes project. I'm also a CNCF ambassador. So if you have questions about CNCF or any of the CNCF projects, you can reach out to me. And you can find me at these handles on GitHub and Twitter. Um, so before we start talking about cloud native and what it is and how you can get involved, let's take a quick history lesson and let's see how cloud native fits into the history of application development. So if you go back to 2000, at that point, if you wanted to launch an application, you needed to buy a physical server or a rack of server, and that was kind of expensive. In 2001, VMware came up with this amazing technology called virtual machines, and you could run so many VMs on a physical machine. This meant that you could actually buy fewer servers, and this was great. Then in 2006, Amazon Web Services popularized this idea of infrastructure as a service, and it allowed renting servers by the hour. So, like, your capex now became more of an operating expense. Then in 2009, Heroku came up, and then it popularized the idea of platform as a service. And the magic of just being able to type git push Heroku, and you could have a new version of your application deployed. Then in 2010, we see the birth of open source projects. If you notice, like the four uh, projects that I mentioned before are kind of proprietary, but from now on, you'll see that we have a birth of open source projects coming up. So in 2010, we had OpenStack, and OpenStack created the open source infrastructure as a service. Then came Cloud Foundry, which is an open source platform as a service. Then in 2013, Docker came along and popularized this amazing magical concept of containers that you can wrap your applications in, and it completely revolutionized the industry. And finally, in 2015, the Cloud Native Computing Foundation, or the CNCF, was created. It's also the home of the Kubernetes project, which you already probably know about and heard about. Um, but before, like, since we're talking about like the Cloud Native Computing Foundation, we first have to understand what cloud native means and what this whole thing is about. So you can, like, very briefly put up, we can define cloud native with three key parts. So first is that you divide your application into microservices. You package each of these microservices and each of these parts in its own container, and then you dynamically orchestrate these containers. So just like recapping the whole thing, you divide your application into small parts, you package these parts into containers, and then you orchestrate these containers. So this is what cloud, like these are the fundamentals of what makes a cloud native. But let's see why people are talking about this journey to cloud native. One of the biggest reasons is to avoid vendor lock-in. You don't want to be tied to a vendor. You want to have choices if you want to move from one thing to another, if you want to have like a slew of features that another vendor doesn't support. So open source helps you with this. Open source enables deployment on any public, private, or hybrid cloud. You can download the software, you can use it yourself, and there's multiple vendors. So you have this choice. You can switch from one to another if you want to. And it also offers a really extraordinary level of scalability. So you might have probably heard about this. So Kubernetes has evolved from Google's experience with their containers, internal container system Borg, and that system launches more than 2 billion containers per week. On an average, that's almost 3,300 containers per second. That's a lot of containers. So you can imagine how how it enables unlimited scalability. And these numbers are like from a few years ago, so it must have increased even more. Another thing it helps you with is agility and maintainability. So splitting up your application such that paths are described separately, it also allows teams which like focus on each of these separate paths to scale better. They can have different dependencies and they can like decouple and work in a agile manner. And also by dynamically managing and scheduling these microservices, you can reduce the cost associated with maintenance and operations. This also allows an extraordinary amount of resilience to failures of individual containers, machines, and even data centers. And if your demand goes up and down, you can also adjust dynamically. And all this is great, but like, what does it mean to companies? What does, like, at the end of the day, it's all business, right? So what kind of effect does that have on business? So studies show that high performing cloud native architectures, they tend to have 200 times frequent deployments, 2000 times shorter lead times, and much faster recovery from failures. So I think the takeaway from all of this is to say that if you're building a new application from scratch, that is a greenfield application, then cloud native architecture is the way to go. It is the default. But let's be real. The real world, in the real world, there aren't many greenfield applications out there. The real world still consists of brownfield applications. Now, we use this term brownfield applications usually to talk about big consolidated applications like a large Java app or a legacy application that's very hard to evolve. Such applications are called monoliths, and nearly all production applications right now are monoliths because cloud native isn't that old. So we still have a long way to go there. But monoliths are the opposite of cloud native because we want small parts, we want microservices. And monoliths are inflexible, they're very tightly coupled, and that makes them very brittle. So, what do we do? The idea is that if you're in a hole, step one is always to stop digging. Don't dig yourself further. So, you need to stop adding new functionality to your monolith in the first place. Once you do that, there's this concept called lift and shift. The idea that whatever your legacy application is, you can actually containerize it. You can actually move it to containers. So people usually think of containers as this very small, agile kind of things, but you can take a Java application that requires 8 gigabits of RAM and you can still wrap a container around it. So if you're getting started with this, within Kubernetes, stateful sets are a feature which allow you to lock a container to a piece of hardware to make sure it has adequate performance. And now this is really the key part of the talk. Uh, you need to start chipping away at that monolith and moving to microservices. You need to break down. You need to figure out the architecture and like break it down and chip it away to move to smaller parts and to move to microservices. And sometimes stripping away isn't enough. So you need a chainsaw to cut away some of the original functionalities and build new functionalities. For example, if you have a performance sensitive task, maybe you can now write it in Go. You can still have an API that calls back to your existing monolith, but this new functionality can be written in modern languages by different teams with its own set of libraries and dependencies. And by doing this, you're splitting away all of that monolith, and you're also introducing modern languages into your stack and making it more performative. So eventually, once you have like chipped away enough, you can evolve your monolith into a beautiful microservice. And hopefully, you can evolve pieces of it all. And eventually, you have a collection of different microservices that are all connected together and they're orchestrated in a single system. Now, all this is great. So, like, we understood what's the history of cloud native, we understood what cloud native means, why it is great, and why is it beneficial, why do people and companies want to move to it. And then we saw how you can move from monoliths to cloud native architecture. But like all of this is theory. How is it really implemented? Now, this can be quite an eye chart, and in fact, like CNCF actually says that this is quite an eye chart. So there are a wide variety of. I think someone on. Okay. So how can this be implemented? So there are a wide variety of projects within the cloud native ecosystem that you can use. And the CNCF, the Cloud Native Computing Foundation, it maintains a cloud native landscape. So this is a huge chart with a lot of projects that you can use depending on the features that you want, depending on your requirements, and depending on what kind of project you want to use. Do you like it has classifications for like uh, container for like data. I'm pretty sure you can't see this, like I can't see this myself, like databases, service mesh, container runtime. So it categorizes all of these projects. It can be useful, but it can be hard to read and can be quite intimidating. So we're going to go over some of these projects in the landscape and see how they help us and try to understand how, like, what kind of projects do you have to look at from if you're just starting out with cloud native. And this chart also like has non-open source project. It also has non-CNCF projects. So it includes all projects in the cloud native ecosystem. But just to know that in the next few slides, I will be covering only the projects that are open source and in the CNCF itself. Okay, let's get started. Um, so we've talked a lot about containers, but you need to wait. You need a way to store these container images if you want to use them. And that's where container registries come in. So for this, you can use an open source project like Harbor, which is an open source registry. And it offers a lot of other features like security, like it secures the artifacts with policies and role-based access control. It ensures that your images are scanned and free from vulnerabilities. And it also signs the images as trusted. Uh, Now, once you have your container image, you have to actually run the container, and that's why container runtimes come in. So container runtimes are basically what the name says. It allows your container to run. So one of the most popular container runtimes is Containerd. It's also the default in Kubernetes. Containerd does a lot of things. It manages the complete container lifecycle. So from image transfer and storage to container execution, supervision to like low level storage to network attachments and a lot of other things. So if you are interested in low level details of how containers work, definitely check out the Containerd project. The maintainers are also really nice. Like I work with them. So yeah, like if you're looking for projects you want to contribute to, that's a really good one too. Now, once you start using containers in your business, you can end up with tens of thousands of containers. You need a way to operate containers at scale, and that's why Kubernetes comes in. I think there's also a session later today where I can like how you can learn Kubernetes. So definitely try to attend that if you can. And for now that we have like Kubernetes, which I won't go too deep into because there is a session today. But like, how do you like what is the management of Kubernetes look like? So like for installing and running Kubernetes, you should select a certified Kubernetes distribution, a hosted platform, or an installer. So CNCF has a certification. It's called and it has like distributions listed on its website, which are certified Kubernetes distribution. That is, they pass a set of conformance tests. So you should want to like look at these kind of distributions to use. Helm is an example of a CNCF project, which allows you to define, install, and upgrade Kubernetes applications that you can also take a look at. Now, one of the most important things in your cloud native journey is to set up CI/CD, continuous integration and continuous delivery, so that changes to your source code can automatically result in a new container being built, tested, and deployed. it is really important to automate all of that workflow to ensure that your developer experience is smooth. At the end of the day, your developers are going to be working on this, and you want to make sure like whatever experience they have is smooth. You want to automate and like automate all that toil. So you can set up automatic rollouts, rollbacks, and testing, and a slew of other things. Argo is one such set of Kubernetes native tools for deploying and running workflows using GitOps paradigms. Very basic term I like to say, like observability is knowing your system to know your business. So for monitoring, to know what for monitor, so like you can kind of think of it as like three parts. So like you can think of it as monitoring, logging, and tracing. Monitoring is to know what happens and when it happens. And for this, you can use Prometheus. For logging, that is to know what happened before, you can use Fluentd, which is also a CNCF project. For tracing, it's about like following where the trail leads and pinpoint where failures occur. So for tracing, you can use an open tracing compatible project like Jaeger. Uh, Now we come up to service meshes, which you've probably all heard of, and it's a huge, complicated topic on its own, so I wouldn't go too much into detail. So service mesh is like a configurable infrastructure layer for microservices that makes communication flexible and reliable in a very basic terms. So Core DNS is a fast and flexible tool that is useful for service discovery. Envoy and Linkerd each enable service mesh architecture, so they offer features like health checking, routing, and load balancing. Now, there are a lot of CNCF projects like these that I can cover, but I will not waste your time. I will try to keep this presentation short. So you can read more about all of these, which cover like things like networking, policy, security, storage, streaming, and messaging. If you go to like github.com/cncf/trail map, it tells you how you can choose projects, like what is the order, like what is the first project you really need to choose. Like first you read Kubernetes and only then you can like choose all of these other projects. So it gives you a proper trail map. So the landscape along with this trail map can be pretty helpful in identifying which projects you can use in your system. Now, okay, so now like recapping, we know what is cloud native, we know how it fits into the history, we know why people use it, and we know what kind of projects we can use for cloud native. But what does it really mean for India? So let's see how you can get involved in the cloud native ecosystem in India. So there are 15 official CNCF meetups across India. They are all highly active and they still hosting virtual meetups. There are also a slew of other non-official meetup groups, but then they're also pretty active. So like if you go to meetup.com and I think if you like search for CNCF meetups, you can get a lot of them. And given that everything is virtual right now, you can also attend meetups of other countries to just get an idea of like what kind of topics they are thinking about. But in India itself, we do have 15 official CNCF meetup groups. And I really highly recommend attending them because you meet other people in the community. You also learn about best practices on how to use cloud native projects. There are also 8 CNCF ambassadors from India. The complete list of who is also available on the CNCF website. So feel free to reach out to these ambassadors in case you have questions. I'm also one of the ambassadors. If I don't know the answer, I will like connect you with someone who does know. So we are very friendly. Please don't feel shy. Say hi to us. Like Ghanshyam mentioned for OpenStack and OpenInfra, we also have several mentorship programs for CNCF and Kubernetes. And more than 50% of these mentees are actually of Indian origin. So that's pretty cool statistic. So some mentorship programs that we run are Google Summer of Code for students, Community Bridge. It's not just for students, like anyone can apply. Outreaches for underrepresented groups in tech. We also have a whole lot of other mentorship opportunities. Like we run new contributor workshops. And then also like group mentoring sessions. So we'll have one or two maintainers and then a few mentees, and then we'll work with them for 3 months on how they can get started with contributing, like whole code review, pair on code reviews with them, walk them through how they can contribute. So it's like it's kind of like one-on-one mentoring, but on a group level. So it's like a group mentoring session. If you don't have enough time for dedicated mentorship, I'd really recommend joining these Slack channels. The Indian community, and when I say Indian community, not just the folks in India, but also people of Indian origin living elsewhere, they all hang out in these Slack channels. This is on the Kubernetes Slack, but not just like Kubernetes folks hang out here, folks from other cloud native projects also talk here. So in dev is for contributors across cloud native projects. In users is for user specific questions. In events is for event related discussions. If you need an invite, you can get an invite to the Slack at slack.kates.io. Um, I also host a lot of frequent Zoom calls in these channels. So most of these are just water cooler discussions. Sometimes we play games so that folks can get to know each other in the community, especially in these COVID times. That's proven really helpful and people have been liking it. So if you want to meet people, it's a good way to join that. So this is how you can get involved and start talking to people, but like how do you contribute back and how do you contribute code to the project? So I want to touch base very briefly on how you can contribute back. And I'm going to be talking about Kubernetes because I know more about it than any other cloud native projects as an example. But I think this kind of holds true for CNCF projects. Almost all CNCF projects out there, the nomenclature might differ a bit, but the process is pretty much similar. So the Kubernetes community is pretty huge right now, and it is divided into multiple groups. So we have something called as special interest groups, we have working groups, and we have user groups and also committees. But like we'll only talk about special interest groups and working groups right now. So the most common one that you've probably heard before is special interest groups or SIGs. So we have SIGs like SIG auth, SIG CLI, which deals with kubectl, and SIG testing. Uh, when I say SIGs, these are the actual groups who own code in the upstream project. Then we also have something called as working groups. They are temporary groups for cross SIG work. So if like SIG CLI and SIG auth want to do some work together, they usually form a working group and work on that. So I'd recommend like choosing, if you want to contribute, I'd recommend choosing a SIG that sort of aligns well with your day job too, because it's easier to contribute back and you won't feel that burnt out while doing it. It's also easier to convince your manager that you're working on something that aligns with your day job and maybe do it during your work hours. So choose a SIG or a working group that aligns with your interest and aligns with your job if possible. Now, once you've chosen a SIG, uh, all of these SIGs and all the other groups have mailing lists and Slack channels, like specific Slack channels for the SIGs, where you can interact and ask questions to maintainers. They also have public meetings that are published on YouTube. Unfortunately, most of these meetings end up in US centric hours. So if you're in India and you can't stay up late, which I completely understand, uh, not attending meetings is fine because we are trying to like move towards async communication these days. We do have meeting notes, and the recordings are always helpful too. And we're also holding APAC version of these meetings, which are in India friendly hours, so look out for those as well. Okay, now you've chosen SIGs, you've like talked to them on mailing lists and Slack channels, attended some of the meetings. It's totally fine to lurk. By the way, you don't really need to speak if you're not comfortable doing that right away. Next thing is understanding the code base. So if you want to contribute code, the first thing you need to do is understand the code base. We have two guides to help with this. So we have a contributor guide and a developer guide in the Kubernetes/community repo on GitHub that can help you get started. Now, the contributor guide covers things like community conventions, what are the terminologies that we use, what is the GitHub workflow, how do you find issues, what are the best practices, and such things. The developer guide, on the other hand, talks about setting up your developer environment. Once you set up your developer environment, how do you run tests? What are the API conventions if you want to make changes to the API? What is the release process and such things? We also have a term called it's pretty helpful. So we have maintainers walk through the code base and they explain what this piece of code, like what does it do, how you can have the Kubernetes project can be pretty huge. It can get intimidating. So having these accessible videos are pretty helpful. Now that you've understood the code base, it's time to find something you can work on. So look for issues that have the good first issue or the help wanted label, because these are beginner friendly issues that you can get started with. And usually these issues, like maintainers, are pretty helpful in providing mentorship for them. But then contributions are not always about code. There are so many other things that you can do, and all of these are really important. Like these are, please don't think of this as not being as important as code, like project management or helping run contributor events, because these are the things that actually keep the community together and the project going together. So, and if you don't have too much time, where if you feel like this can be a little less of a time commitment for you, show up, because you can get to know other people and you can find other avenues that you can work with. So a lot of people get started in the communities project through these means of contributing. Now, once you get started with contributing, you can move up the contributor ladder. So we do have a ladder on how you progress as a contributor. First, you would become a member of the Kubernetes GitHub organization. This is actually kind of a low bar, to be honest. If you submit a few PRs and issues and you review like 5 to 10 PRs and issues, you can become a member pretty easily. Then you'd become a reviewer, if who'd be reviewing code, and then an approver where you can sign off on changes to PRs, and eventually an owner who sets priorities and provides leadership for these subprojects. Other than this, we also have leadership positions like SIG leads. I'm a technical lead for one of these SIGs, so we have chairs and technical leads for each SIG. And we also have the steering committee, which looks over like all of these SIGs and all of these groups. So we do have other leadership positions, but this is the normal path and the normal ladder for contributors. So yeah, that was pretty much it. So this was an intro on what cloud native is, how you can move to cloud native, how you can move from cloud to cloud native, and how you can get involved and contribute back. I also really love this picture of the CNCF meetup in Bangalore from pre-COVID times. Um, I hope we all get a chance to meet again. And yeah, please don't feel shy in getting involved with this community. Everyone is really friendly, very helpful. We use emojis, we use memes, we have a lot of fun. So feel free to say hello anytime. And thank you. So
So
yeah,
let's open
that's
out the floor for questions. Anybody has any questions for Nikita? She's the first
Thank you,
timer on the OTF.
Nikhita.
Yep, go
I
ahead.
have one question. Where do we find those code review videos?
Sure. So I can also drop a link somewhere, maybe in the Zoom chat. But if you go to the Kubernetes YouTube channel and just there's like a playlist which says code-based tool videos, or you can just
Cool.
search in Google like code-based tool videos. Yeah.
Okay,
Yeah.
thank you.
Sure. Any more
So,
questions?
yep,
Just
if nobody is
one
there,
question.
yeah, go ahead. Who is it?
Yeah, Ghanshyam here.
Gansham, yeah, go ahead. Yeah, sure.
Thanks, Nikita, for really nice session and very informative. I also really like the code tour idea. So, from one question from the steering committee point of view, like how steering committee plays role to maintain the like the common thing and the standardization between all the Kubernetes SIG in terms of their process as well as in terms of their like the software development side.
When you say maintaining standard, what kind of standards? they have.
So it's like if they are providing the interface, so to have all the Kubernetes, it provide a standard or follow a standard guidelines for those interface, those kind of things.
Got it. So steering committee tries to be a little hand-offish when it comes to such decisions. We don't want to seem overbearing. So we do have we try to delegate as much as possible. But we do have a SIG or a special interest group called architecture, which lays down these API. So like we have this huge doc called API conventions. So all SIGs need to follow these conventions and you cannot deviate from there. So a lot of us actually on the steering committee, like even I participate in SIG architecture, so we wear a lot of hats in the project, but it's not the steering committee which does this. It's the SIG architecture group which lays down conventions and patterns that all SIGs need to conform to, and we also have like automated tests which make sure that they're not deviating from it. Does that answer the question?
Yeah, I think thanks.
Yeah, actually, to tell you, DIMS from architecture committee recommended Nikhita. So I asked him, hey, would you like to come? He said, no, the right person for you is Nikhita. She is interested in India and you have to go to her. And that's how I came to Nikhita. And that tells that she is dealing with the architecture committee really, in the steering committee with architecture people. Any questions, Digambar? I'm putting you on spot.
Yeah.
You want to
No,
ask?
no, no. I know Nikita and Deems. I think we have been active in India in Dev Slack channel.
Yeah.
So hi Nikita. Yeah.
Hi.
Okay. I think good. They are doing good for all over India, and Nikita is organizing a lot of events, and she's kind of hosting all the events all over India, CNCF events. So nice. I think good to see. I think our people in CNCF and contributing a core architecture group.
Yeah,
Yeah,
and they were like also thank you for showing up on that in-depth channel. I know like you've initiated some conversations around hosting meetups and such too. So that's kind of important to see involvement
Yeah.
and people taking initiative. Thanks.
Yeah. Sure. Yeah. Yes.
So
I
with
think
that,
Yeah.
go
we
ahead.
will have
Next
many
question.
conversations. Yeah. Go ahead.
Ganesh, you wanted to?
Okay, Nikita, this is definitely a good session. Ganesh here. So my only one point agenda here is how best we can leverage the engineering students to start contributing back to the open source community, because it should not restricted to only the small portion. I do know that some of the universities do participate in Google Summer of Code and some of the open source driven initiatives. So I am more keen towards in the CNF contribution. Do you guys have any plan or anything you would like to share in this forum or outside? Either way is fine.
Yeah, no, I can touch base upon some of the stuff. So incidentally, I started in the Kubernetes project as an intern. So I was a Google Summer of student like 3 years ago myself. And so we do have Google Summer of Code. That is the most famous internship program. We also have Outreachy, which is not really limited for students, but then a lot of students participate there. Uh, we also understand like some folks don't get selected in Google Summer of Code or Outreach or don't have time commitment for that. So there is another program that CNCF runs called Community Bridge, which is similar to this, but the entity running this is the CNCF itself. Actually, the Linux Foundation, I think. The price amount, everything is similar, or I think even more. So it's kind of the same. Like students can choose more of a flexible timeline. So instead of a more rigorous timeline like Google Summer of Code for open source projects that they can work on. Other than this, so honestly, like we've had a lot of interns come in through these three programs, but then so all of these interns hold mentee and mentorship calls regularly, and they invite a few of the maintainers each of these meetings to talk about people, and like lots of students attend such calls too. So there is an active student community involved. Most of them do show up through internships, but then they stay along, and then like they're encouraging the students to come up. So yeah, and like in general, also like the in-dev channel that the Gampar was mentioning, uh, many students show up and ask questions there, and we try to help them too. So that's another way to just say hello and get started.
Okay, thanks. Yeah, we can definitely sync up and then plan some more
Yeah,
things. What I'm thinking anyway. Yeah, sure.
yeah, sure.
Anyone, anyone wants another question before I ask my last question? Okay, first, thank you very much, Nikhita. You are from Mumbai, Amchi, Mumbai. I am also from Bombay. Uh, from
So I
from
don't want to say morning vada pav session.
yeah. So
Yeah, we all love Mumbai, right?
yeah, that's
It's
true. So
heart of India.
yeah, that's true. It's part of India. It is so. Just a recollection that I used to teach software engineering to engineering college final year students in the year 88, before 88, 86 or so. So at that time, I used to talk about Putnam model and
Do
I
we
cannot
do we
hear.
lost?
Yeah, yeah.
I
Thanks.
think we lost him. Looks like
so
Prakash.
still the process is.
Prakash, we lost you when when you were talking about teaching about something.
Oh, okay. I was talking about I taught software engineering for the engineering college student final year, and those days I used to talk about Putnam model and function point estimation so that we can reduce the time to uh, improve as well as to deliver faster. But I have realized that in spite of whatever agility you bring, you still need a process. And that is what the process, and that is why the architecture people decide more, and other people more interested in coding just jump and code. It's like fast fail. You fail fast and then move on, and you don't. So initial phases, if you can get through, then only you can really become a committer to the contributor, contributor to committer to the highest level of ownership. So it's still challenging in spite. And so I'm very happy that we have Nikhita who has passed through all that and all the fresh. So you start your history from 2000. That's what I saw. If I were, I would have started from 60, maybe with IBM, COBOL, football, snowball, all that. So interesting. Perspective change, generations change, eras change, and I'm very glad that we have leadership in your hand and other people who are in your group. And we look forward to following the leaders. That is our goal now at this stage. And hopefully you will lead us to better destiny, become more as India producers than just the consumers of the software, and for the software for India in itself, like government, for the industry, which is local. We served, but we served the lords, and lords have gained, and hopefully we will gain at some point of our people in country. So with that, I think I'll bring to end, thanking Nikhita, and you need to come for your award ceremony in the evening. We have awards for few of contributors to the community who were nominated, and we like to see you there. And we will have a lunch break, and in the lunch break there will be one Kubernetes session which I had recorded for CCICI. I'll just put it, and if people want to stay and listen, they can do. Otherwise, we have almost a 1 hour break, and then we come back after that. And Ganesh will be the master of ceremonies for that. We have a full day session. In the afternoon session, it will be what is OTF going to do, that type of thing, and then followed by health IT. Our this year's vertical we are chosen is health IT, which will be focusing in the area at the end of this in the August 15 timeframe. There is a hackathon on 26 Jan. And so that's the plan for this year. And other things Ganesh will share with you in the afternoon session. And then we have sessions by the training people on the CKA, CKAD, CKS certification. Then your colleague Sayyam has some 15 minutes recorded session he has given from CNCF for the Kubeflow, especially related to Jupyter terminal usage on the. And so that's the line of things we are going to do. And then we have Digambar for the Metal Cube, and two professors for their what they have done for their schools and how they are improving the FOSS and what we call as skill set improvement using open source. And then we'll have this award ceremonies. So with that, I will just wrap up for the morning and the keynote session. And we thank you very much, everyone, for the contribution. And I will stop recording here at this time. And thank you, everyone.